Hello, this is Mr. Esty, and we're here to look at how we can use Google Sheets to weight our survey responses using the raking method. The reason we're going to do this is because if our survey wasn't quite representative, if the sample wasn't quite representative of the population, if there was some kind of demographic mismatch, like there wasn't a balanced gender breakdown of our sample, or there wasn't a balanced racial breakdown, or zip code breakdown, or age or grade breakdown, then we can use weighting to sort of correct that imbalance and see what the data would have looked like if we had had the representative sample we were trying to get. First of all, we should just remember how the raking method of weighting works. So first we find the design weights or the sample weights, and this is just what we are trying to get in the sample. So for example, if we're looking at the design weights of students in a high school by grade, then typically you're going to have about 25% of the student body in 9th grade, 25% in 10th grade, 25% in 11th grade, and 25% in 12th grade. So your design weights would be 25% for each grade. So if the general population that you're looking at is 25% ninth graders, then that means you want your sample to be 25% ninth graders. So the next thing you need to do is sort your survey results by category, by statistical unit. In this case, if we're talking about ninth graders and 10th graders and 11th graders and 12th graders, that's your statistical units. So you want to break down the answers by, okay, what did ninth graders say? What did 10th graders say? What did 11th graders say? What did 12th graders say? If we're talking about gender, which is what we're going to talk about in our example, then we want to look at, okay, if our question had the options yes, no, or maybe, then how many women said yes, how many women said no, how many women said no, maybe, how many men said yes, etc. Then we're going to use that information, the design weights, to figure out the weighting factor. And we're going to do that by taking the design weight, multiplying it by the size of the sample to get the desired number. That's the number of people from that category. For example, the number of women that we wanted in our sample to be representative. And that's our desired number. We divide that by the actual number of women who actually responded to our survey, and that gives us our weighting factor. That ratio is the weighting factor that we will use to multiply all of the results. So the weighting factor for women, we will take that. It will be some kind of decimal, either above or below 1, and we'll multiply every response that was given by women, we'll multiply that frequency by the weighting factor. So for example, if 9 women said yes, we'll multiply that 9 by the weighting factor for women. If 10 men said no, then we will multiply that 10 by the weighting factor for men, and so forth. We're going to start by finding our design weights. And to find design weights, I'm looking at our school. So assuming that we had the entire student population of our school as our population, that's what we're trying to represent with our sample survey, there are 499 students in our population. There's actually 500. There's one student who wasn't reachable by the survey. It's okay. So 499. And of those, my students helped me with this. So the official figures do not include non-binary students. There's no way to have non-binary students' genders represented in the official records right now. They have to be recorded as either female or male. So we went with the official figures, which gave us slightly more than 250 female students and slightly more than 240 male students. My students helped me come up with an estimate of 25 non-binary students in our school, and so that will give us approximately these numbers. These are the numbers that we have. Ideally, you would get exact numbers from an official list. We didn't have an official list, so we did the best we could. Or rather, we had an official list, but it wasn't going to work. If it's true that our school has 5% of our students identifying as non-binary, then leaving out non-binary students is actually going to seriously mess with the data, and we can't do that. We have to be more careful than that. All right, let's find our desired numbers. Let's focus on one category at a time. We're going to start with the biggest category, which is female students. So students who put down their gender as female in our example study. What we're going to do here is we're going to find the desired numbers simply by taking this design weight, these design weights, and we'll multiply it by the number of people in our sample. So looking over here at our completed data table, which we put together in other videos, we found that the total number of students in our sample was 43 right there. That's 43 total students, which means that the number of students that we should have in our sample who identify as female should be 43 times this weight right here, this design weight. And I don't even need to use a calculator here. I can use Google Sheets as my calculator. I just put in equals 43 times, and then I select the cell that has my design weight. All right, so that's my desired number. And I am not going to round this desired number because I don't want to round until I'm done with my calculations. There's no need to round now. It will just make our answers less accurate. Then now I have a desired number, so I need to find the actual number. And again, I can just go straight to our table that we already have. And for female respondents to the question of what is your favorite dog breed, we can just total that up. It totals to 21. And you can see we use the sum formula to find that. But you could have also just added it up by hand. There were 21. All right, so 21 actual female students answering our survey. Now we'll find our weighting factor. So you can see all this. So to find our weighting factor, we are just going to do the formula desired number, so equals this number divided by actual number. That's it. We just find that ratio. And again, we're not going to round here. There's no reason to round our data when we're still in the middle of calculations. That will just make things less accurate. So we have our weighting factor for female. Fantastic. All right, so here we have our data table of the unweighted data. Let's focus on the female column. We can just copy this and we can put it right here, put it right there. And I'm gonna delete all this. We don't want that. And all we need to do here is just say, I want to know what happened in this row, and then I want you to multiply it by the female weighting factor. That's it. And there we go. Now, this is actually a big decimal. It's a big decimal, right? We'll worry about rounding in a second. But first, let's just let it stay a big decimal. Now, before I fill down, I want to do this as quickly as possible, especially because weighting can be a pretty long and complicated process. So before I fill down, I'm just going to put a $sign right there in front of the 18. And that's to hold the weighting factor right here. I do not want it to go down here for the next row. So when we fill down for the next row, you can see now it's still gonna look at the female weighting factor. So it's still getting the right weighting factor. However, now it's not looking at the Doberman row from the original table. It's looking at the German Shepherd row. So we're letting the 3 go down to 4 and then 5 and then 6, but we're not letting this 18 change. That's what the $sign's all about. Now that I know this formula works, including the dollar sign, I'm going to fill it down all the way. And I'm even going to take this and fill that one down, which it should work just fine. Just unround it very quickly. All right. So now we have all of our data weighted. However, now that we've finished our calculations, we do want to round these off because it's not really meaningful to say that there were 2.94 whatever female respondents who chose Doberman. There's no such thing as 0.9 of a respondent. If I want to keep going, if I wanted to, for example, make this into a relative frequency and say this percent of female respondents chose Doberman, or this percent of female respondents chose Husker, then I would keep it unrounded. But if we're done here, and if you're doing my project, you are, I'm going to use this decrease decimal places button, and that's going to automatically round for me. So just going to decrease it down, and I want to get a whole number. I want to get an integer. And in fact, I can highlight all of these numbers, and I can do it all at once. Let's just get it down to an integer. As it turns out, our sample was very representative, and the actual number of female respondents was almost exactly the desired number. So our weighting has made almost no difference whatsoever, which is great. Now, if you are doing my project, you're done here. This is all you need to do. However, if you want to finish weighting the data completely, then we need to do all the categories. It's not enough to just weight one category in most situations. So we can quickly do the weighting for the male respondents just by copying our responses from before. So we had this 43 times Q3. And we're going to have 43 times Q3 as well. 43 times Q4. So we just got all the desired numbers we need very quickly, very easily. For actual numbers, I already have them here. Right? We already know that there are 18. There's 18 male respondents and 4 non-binary respondents in our sample. So we'll go down here and we will calculate the weighting factors the same way as before. So this was P8 divided by P13. As a matter of fact, the way I've set it up, I can fill down without even worrying about it, and it will give us the correct weighting factors for male and non-binary. I will note that while the female weighting factor is very close to 1, and the male weighting factor is pretty close to 1, then the NB weighting factor is actually pretty far away from 1. It's just above 50%. It's just above 0.5. The rule of thumb for weighting factors is that any weighting factor below 0.5, which is the same as saying any factor below 50%, any weighting factor below 1/2, and any weighting factor that's greater than or equal to 2, which is the same as saying greater than or equal to 200%, is a red flag. It's not a weighting factor we can trust. In this case, even though this isn't below 0.5, the fact that we're weighting based on 4 responses is not great. It doesn't give us a lot of confidence in the weighted number. Now, the weighted numbers for female and male respondents we can be confident in, but when we write up a report of our findings for this survey, we're just going to note that we should take the weighting for non-binary respondents with a grain of salt. We shouldn't really put too much faith in it because it's really hard to draw any serious conclusions based on just 4 people's opinions. To be honest, even 21 or 18 people is a pretty small sample size to draw major conclusions. And if we had a lot of resources and a lot of time and we were doing this professionally, we'd probably want bigger sample sizes in general. Moving on from that, however, that doesn't, whether our weighting is justified by our sample size or not, has no bearing on whether or not we can do the math. We can still do the math the same way, which is we come over here, and you can see where we already have the male frequency and NB frequency weighted. All we had to do is just say, all right, go to this formula, go to J3, where we have the first row of data for male respondents, and multiply it by this weighting factor for male. And then we filled all the way down. So we did it for every single row in the table. We multiplied every single row, every single cell in column J that had data for male respondents. We multiplied it by the same weighting factor. That included the very last row where we had the total. And so now we have our weighted data. And you can see the weighted data is a little bit different from the original, right? The original, we had 18 total respondents. The weighted data says actually we should have had 20. There's places where we had only 1 or 3 respondents. And here it says, hey, some of the time 1 should have turned into 2. Honestly, though, it didn't change the data all that much. And again, we used this button to round. We did the same thing for non-binary respondents. We just went to the K column where NB responses were already recorded. We said, go to the K column, check K3, multiply it by our weighting factor for non-binary respondents. Let me make sure that we're actually doing that properly. Yep. And we just did that for the entire row. And in the end, it says we should have actually only had 2 non-binary respondents. We were a little bit overrepresented on non-binary respondents, which is actually perfectly fine. Often when you have a relatively small minority within your overall population, you might want to oversample that population. And that way you'll have more people's responses to work with if you end up weighting. Okay, and then finally, we can just do the total here, where you can find the total either by, you can find the total simply by using the sum formula and saying you just need to add all these up. So equals sum, and then add this, add this, add T3 all the way to V3. And that's going to add it up. And just scroll all the way down. You just fill that all the way down. Equals this. And we're going to fill that in. And so what we have here is now we have a new set of totals. So you can see this is what the frequency looked like with the unweighted data. And we can put it next to the weighted totals. And we can see it's very similar, but there's a few differences. For example, common Doge was a little bit less popular when we weighted the data. We can see that there were slightly fewer Dobermans chosen when we weighted the data. And so when we're writing up a report, we might note that we are sampling, if there was any problem with getting a non-representative sample by gender, it doesn't appear to have made much of an impact, but we can say that maybe we might have slightly overestimated the popularity of the common Doge, and we might have slightly overestimated the popularity of the Doberman, and meanwhile, we might have slightly underestimated the popularity of some other breeds. So overall, that should give you an idea of how to set up a Google Sheets spreadsheet to do demographic weighting using the raking method. And I hope that this will help you go through your samples, go through your survey results, and if necessary, adjust them to make sure that they are properly representing any relevant demographic categories. You could do this with gender, of course, but you could also do it with grade, age, race, home zip code, income level, any demographic category you can think of. This same method can work for that.